We're not even late. All right, this is awesome. So, welcome everyone. This is the OpenXR BOF here in the Kronos BOF Day. Thank you for coming. So you have two presenters today. I'm actually going to start and give some of the ecosystem context for OpenXR, and then we're fortunate to have Arjun here with us, who is also from NVIDIA using OpenXR. You're welcome to sit. You don't need to, but yes. We'll go through, and then Arjun actually knows about OpenXR. I'm just faking it. But we're happy to answer any questions that we can. Okay, so in case you haven't come across OpenXR before, OpenXR is a API to AR and VR runtime engines. So it's a open standard. It's obviously from Kronos. It's royalty-free. It's extensible. All the normal things for a Kronos API standard. And the idea is that we want to reduce the significant friction points that were previously in the industry, people having to write to multiple different hardware APIs. We want to enable people to create cross-platform immersive experiences using AR and VR hardware. So actually very similar to the diagram that the Inari folks were just showing, that the classic defragmentation goal of a cross-platform API. Before the Inari API existed, I'm sure many people here are probably aware that all the hardware vendors were by necessity creating their own runtime APIs for controlling their hardware. But it was a good opportunity for standardization because I think the hardware community, the hardware XR community, realized that everyone was using the same basic API, but everyone was just doing it differently because they designed their own APIs in isolation. And so there was no real value to everyone doing it differently. A classic situation where the timing was right and the industry desire was strong to come together and let's just design collaboratively a single API that we can all use on our hardware, and then the software community, whether they're writing applications or engines or libraries, have a single API, and they can write once and run anywhere that supports a conformant API that is conformant to that Inari specification. So that's the story, and the good news that will and the desire in industry indeed turned out to be real, and Inari hit the right timing window and has gained significant adoption throughout the industry, to the point, I don't think it's an exaggeration, there isn't a major XR device out there nowadays that doesn't support OpenXR. So it's a real opportunity to continue the evolution of the standard. It's a responsibility of the OpenXR working group, to continue that evolution, to continue to meet the needs of the industry, because we do have this opportunity to really provide this value to the industry. So right now, this is the devices that are out there that are fully OpenXR conformant, which means they not only have they implemented the OpenXR API, they've become OpenXR adopters, gone through the conformance testing process, and have passed the conformance tests. And that means, as well as having that badge of honor, they are also enjoying the patent protection of the Kronos IP framework, which is no small advantage to these hardware vendors. And you can see it's quite a range of different hardware. So there's the HoloLens, which is a visually see-through device. There's video pass-through devices. There's VR devices. There's even stereo displays, not even worn headsets. So, and that's good because it shows that the design of the Inari API is flexible enough to be deployed on these different styles of hardware. So the timeline for OpenXR, there was a lot of fragmentation. It inspired the creation of the working group in 2017. And the working group did a good job, 2 years from creation of working group and a blank sheet of paper to a 1.0 spec release. That's pretty good going. The group did a good job in really establishing baseline functionality to enable XR apps in the 1.0 spec. And then after the spec was released, that's when we spent a lot of effort recruiting new hardware vendors that weren't already in the group to come and implement and become conformant. And we've now, just a few months ago, in April 2024, released OpenXR 1.1. It's actually a significant release. It marks a milestone in the working group's effort to build this meaningful ecosystem. Because 1.0, when it released back in 2019, like all Khronos APIs, it's extensible. So any vendor can implement a vendor extension. You don't need to ask permission from anyone. You can go, don't tell the working group, but we welcome people to come and have the discussions in the working group. But OpenXR 1.0 provided an experimentation platform because back in 2019, there were still some things that weren't decided on how best practices for OpenXR. So OpenXR extensions came out from a lot of different vendors doing good experimentation. And that's proven to be a very productive and valuable experience. The downside, of course, is if you don't control that process to the extent, you have so many different extensions from different vendors that fragmentation, of course, becomes the potential problem. So OpenXR 1.1 in April really marks the beginning of, I say, the next phase of OpenXR's evolution. The working group is now focused not only on developing new functionality, but consolidating that experimentation. All of those vendor extensions, the working group is going to pick the best or merge good aspects from the extensions that are being tried out there in the industry. We have lots of feedback coming in. We need more. We can never get enough feedback, so please provide us feedback. But make sure we focus on consolidation to avoid fragmentation, provide more portability, as well as explore new use cases. So going forward, you can expect much more regular OpenXR core release updates that bring new functionality and consolidate. Normally on Khronos APIs normally is approximately an 18-month. That's like the median cycle time. Obviously, it depends on the situation and the market. But I wouldn't be surprised if OpenXR kind of falls into that kind of rhythm. If you go much faster than that on a regular basis, it becomes too difficult to, you're actually moving too fast. People can't keep up. So 18 months seems to be a good rhythm. And I would expect, though, 1.2 probably in 2025, so because we have some consolidation to do. The other aspect of, well, not the only other aspect, another aspect of adoption is adoption by the engines, because many people, of course, access OpenXR functionality not directly, but through their favorite engine. Unity, of course, is probably the most widely used. Unreal, Godot. There are a bunch of engines here on the slide. And they all have OpenXR backends. One particularly near and dear to my heart, because I do stuff in the web ecosystem, are the WebXR engines that are built into the major browsers. They actually do, I'm going to slip one slide, the WebXR engine has the OpenXR native API as its default backend. So WebXR is a JavaScript API. I'm sure many of you use WebXR. The OpenXR working group is working hard to make sure that we provide everything that we need to give to the WebXR folks so they can avoid having to write to dozens of different pieces of hardware. And this is an ongoing example. We have a good working relationship between W3C that develops the web stack APIs and Kronos that typically develops the native level APIs, though we did sneak in WebGL, but WebGPU is now at W3C. And this is a good way of working. So Kronos focusing on native, and W3C working on the JavaScript. So yeah, and we look forward to an ongoing productive relationship with the WebXR folks. And the last thing I'm going to talk about before I hand over is the other axis of adoption is our applications actually using OpenXR. It's important because this is a motivator for the hardware community to implement OpenXR. One of the advantages from a hardware vendor point of view, of course, if you OpenXR, you suddenly get access to this big and growing library of applications and libraries and engines that immediately run on your hardware without you having to go out there and create that whole ecosystem yourself. It's the natural networking benefit of adopting an open standard. And this is by no means an exhaustive list. This is just kind of some of the applications that you may most probably recognize. You'll see there's a whole variety from professional authoring applications like Blender, scientific visualization, power review, games, War Thunder, that's my favorite game. I actually use VR in War Thunder using OpenXR. I feel it gives me joy. So yeah, so the adoption story is going really well with OpenXR. But with that, no, you can do that. Yeah. So yeah, let me hand over to Arjun, who's going to go into a little more detail. You okay to talk about? Yeah, okay.
Hello, everyone. Before we get into the nuts and bolts of OpenXR 1.1, in addition to WebXR, there's also the Monado open source runtime that is completely standards compliant with OpenXR. It's cross-platform, it's open source, it supports AR and VR, and it is built using permissive licenses. So that's pretty important to us in this community and working group that as many folks can utilize these technologies as possible without restrictive licensing. Okay. For OEMs who want to build an OpenXR runtime on a new hardware platform, Monado provides libraries, components, template drivers, scripts, etc. that'll enable them to develop and build new components. For example, a new XR compositor if they so choose. Since it's developed and maintained in an open source manner, the entire ecosystem can collaborate and build on the joint Monado codebase. Monado now runs on Linux, Windows, and Android. Okay, let's talk a little bit more about this ecosystem of which, WebXR, Monado, and so many applications and runtimes are now a part of. What are the core components of this ecosystem? I think the beauty of the OpenXR spec is that it does not specify implementation details, just like many of the other specs that you've heard about today. company code still remains confidential. And for example, it doesn't specify how to obtain tracking data from the device. OpenXR is also an extensible API, so it grows through the addition of new features, similar to the other Kronos APIs, of course. Extensions can expose new functions or modify the behavior of existing OpenXR functions. It's also designed to be a layered API. That means that a user or an application may insert API layers between the application and the runtime without the runtime having to change its code, or the application having to change code if the user is the one injecting these layers. They're optional layers, of course, and they can modify existing functionality, including the functionality of extensions. And we'll talk a little bit more about how that was crucially important for NVIDIA a little bit later on. Because implementations can vary and are on a wide swath of hardware platforms, the conformance test suite enforces the correct behavior from the specification. Products that pass the CTS are guaranteed to work the same way. Therefore, application developers don't need to test their app on each individual headset. For a runtime to be conformant, you need to pass CTS and follow the other steps in the API adopter process. I'll just finish with a few words about the OpenXR loader. This is a key component of OpenXR that instantiates the user-specified runtime in a platform-specific way. This abstracts the specifics abstracting these specifics away from the application. It also manages API layers, allowing the application, the user, or the environment to inject their desired behavior at runtime. Let's dive a little bit deeper into the OpenXR API layers feature. OpenXR API layers allow you to intercept and modify API calls between the application and the OpenXR runtime. So you can develop modular components that allow you to do validation, debug, or extended functionality. You can isolate different functionalities into distinct layers without impacting the runtime code. This gives you flexibility to add and remove features without modifying your application. You can debug or add additional logging capabilities by intercepting and analyzing these API calls, or you can create completely custom behaviors or extensions layered onto the existing APIs or other extensions. A few notable examples are the OpenXR core validation API layer, similar to Vulkan's validation layer, for example, or the UltraLeap OpenXR hand tracking layer. And I'd actually like to talk about how NVIDIA used the OpenXR API layer system to build a Unity client plugin for NVIDIA Cloud XR. So as many of you probably here use Unity, Unity under the hood, as Neil mentioned, is using the OpenXR interface to be able to communicate with applications. But Unity is also designed to be a higher level programming abstraction. So it rightly abstracts some details away from the application, such as pose prediction. It will give you a pose, and it'll tell you to render that pose, without giving you specifics about when that pose was valid, how much prediction was done on it, so on and so forth. However, for a streaming use case, that isn't sufficient for us to be able to do a full round trip of sending a pose to a remote server that may be tens of milliseconds away. We need more granular information than that. And we were able to make our Unity client plugin work without having to rewrite any Unity source code, without having to ask Unity to rewrite source code for us, without having to make changes to any OpenXR specification or even add a new OpenXR extension for this pose information, by simply adding a few OpenXR API layers that allowed us to get additional pose information, including how much pose prediction has already been done on those poses and all the other additional intrinsic information that we need to do our own pose prediction in the cloud. And this plugin has enabled Cloud XR users to build a client for any Android HMD that supports OpenXR. To date, we've validated all the Quest devices, HTC devices, Lenovo, and Pico, among others. It's a very powerful feature, and I encourage people to look into this. Let's talk a little bit about OpenXR 1.1, much anticipated release of the spec that just went live in April. We've been able to consolidate multiple features from this very powerful vendor ecosystem into the OpenXR core specification. And what that means for OpenXR application developers who develop against OpenXR is that more functionality is guaranteed to work in more places without any additional hoops to jump through. And we think that is kind of the key to making OpenXR successful in the future, having this robust pipeline of extensions which start in the vendor space, then as they build momentum and popularity, get promoted to extensions, Kronos extensions, and then eventually, if they really are core pieces of functionality that can be completely platform agnostic, go into the core specification itself. In addition to that, there were a number of OpenXR feature enhancements that were much requested. We'll go into those in a little bit more detail. And the future is bright for OpenXR. As Neil said, you can look at the other Kronos APIs and get an idea of how often you can expect future updates. 2025 is probably the next time when you'll hear back from us in a big way about what's coming next. But philosophically speaking, we want to encourage this ecosystem to keep building cool things in the vendor space. We want to keep promoting those things to extensions, and then eventually, in the next major release, have a new set of core features that we can talk about. The other main thrust is to really drive forward experience portability. So improve the quality of our conformance tests, make sure that we are encouraging vendors to write their extensions in such a way that they can be promoted into Kronos extensions, so on and so forth, so that the maximum number of applications can run on the maximum number of devices. So let's talk about the extensions that were promoted. The first one is the local flow reference space. It's a gravity-aligned world lock space for standing content. It's also got the estimated floor height, the height from the floor built into it. And the key reason for doing this is that a lot of applications were using the stage space, which really reflects the center of your play space. That's not a space that is meant to move without a calibration step, that initial step where you put on the headset, you mark out the edges of your space. That is your stage. Whereas the floor space is really supposed to be a more dynamic thing that the user can recenter as they move around that stage and change the orientation of all their content. So this additional abstraction we found to be tremendously useful for a bunch of different applications, and so this was promoted into the core. And this way, when you do a recenter, there's no implied assumption about recalibrating your space. You're just moving your floor position in your existing stage space. The next one is grip surface. So as more and more applications, as more and more devices, in fact, I think from the slide that we saw a few pages earlier, there are very few XR devices that are not actually fully capable of AR at this point. Hand interactions and being able to see content with your hands, occluding the content is becoming the norm and not an exception. So we want to have input modalities that track your hands, and we want to have anchors that allow you to position content, UI, game elements, whatever you might want, in relation to those, in relation to the user's hands. So we also promoted those extensions to be part of the core API. The next big one was for anybody who's used the Vario family of devices. They offer an incredible amount of visual fidelity, and the way they're able to do that is by making the most of the GPU's rendering capacity by doing foveated rendering. So they have a high resolution inset, and then a larger peripheral area that's rendered at a lower resolution. And that way you're able to get the frame rates that you need, the user experience that you need, without actually rendering 8K pixels per eye. We looked at this extension, and it looked like something that would be useful, for possibly other hardware implementations, but also for multiple applications to, pick up and start using foveated rendering. Omniverse being NVIDIA Omniverse being the latest in a long list of examples of people picking up this technology, because it really allows you to get the most visual fidelity out of your GPU. The way this works is, of course, the application renders 2 views per eye, but because only one is at really high resolution, you're able to still hit your frame rate targets. And finally, there were a bunch of additional enhancements, including improvements to the interaction profiles, better and more clear documentation around the spec and the language in the spec, and clarifications on certain points that people may have found a little bit confusing. So let's talk about those in a little bit more detail. There were 13 new interaction profiles added to the core specification, and most of them were actually promoted from vendor extensions. There were some standard identifiers that were added to the language, for example, thumb resting surfaces, stylus, trigger curl, trigger slide, and many other things that we think you'll find very useful in building your applications. There are new output paths, for example, haptic trigger and haptic thumb to make haptics easier to surface from within your applications. We also improved some of the kind of core fundamental concepts within the OpenXR API specification. For example, how to use XR durations with negative durations, what that negative duration means in the context of a timeout, better language and syntax around event polling, more clear and concise language around the to-call idiom of calling the API with a count and then allocating the memory for the number of returned elements and then calling it again, making it very clear what that API does for every permutation and combination of inputs that you might pass into it, and adding a number of new structures that allow you to interface with our API better. For example, XR color 3F, color without alpha. In addition to that, we added a bunch of new error codes to make it clearer when something goes wrong, what exactly went wrong, and more language around which reference space to use, the floor space, the stage space, the local space, for example, which pose identifier to use for your hands, grip, aim, etc. And also made it clearer which extensions which pieces of the core functionality are now cross-platform and you can rely on without needing to do any additional validation in our conformance spec. So OpenXR 1.1 was released in April. We've already updated the OpenXR SDK to 1.1.38. That was released June 2024. Some of the things that we added in this update were a new composition layer for inverted alpha when 0 to 1. The meaning of 0 to 1 for alpha differs among different game engines, and we wanted to have that supported at the extension level. So we had all the information preserved when it got to the OpenXR compositor of the meaning of that alpha buffer. Also some clarifications to the specification and API for the composition layer pass-through extension and the plane detection extension. We've also updated the conformance testing suite in June. This is now 1.1.37. It does OpenXR conformance testing by default. However, it also supports OpenXR 1.0 mode, and so it is the new default going forward, whether you want to test your application for 1.1 or 1.0 conformance. You use the same CTS suite. There were some new interactive tests added, and other improvements for haptics, action fixes, and parameter tuning for the grip surface. We've also improved the reporting of the conformance testing on Android, so we give you more feedback about your application's performance when you're, how your application will perform on Android runtimes. And let's talk about what's coming next. We're going to extend the hand tracking and also to include full body tracking. We're going to enhance the handling of spatial entities, which I'll talk about more in a little bit. But standardize, as I mentioned, XR devices are now all AR devices. And so being able to understand the space in which the user is in and helping them to interact with that space in a natural way is going to become a key component of all these XR applications. We've expanded the haptic support, and we've also, we will be expanding the haptic support and adding controller rendering models via GLTF. Animated controllers, which kind of respond to the state of the controller, the physical controller. Okay, so let's talk about spatial entities. We want to standardize the method by which the application interacts with the user's environment. That includes being able to recognize and anchor content with planes, objects, the world mesh, spatial anchors, all kinds of marker tracking, and everybody in the ecosystem is excited for this to just become a standardized piece of the OpenXR specification, because this is the new frontier where things are starting to get quite interesting, but also quite fragmented. Every runtime vendor has to kind of come up with their own way of allowing you to interact with these different entities, and we think it's a perfect time to start to bring that under the umbrella of the API. Okay. You're going to have access to this deck after the presentation, but this is the slide that you'll probably end up at. It's got all the helpful links that help you get started with OpenXR, the OpenXR SDK itself, our reference pages and guides, beginner tutorial that is actually one of my favorite tutorials that I've run through in a while. It's quite nice. The conformance test suite that will validate your application and guarantee that it's going to run the same way on every headset that is spec compliant. And of course, all of our support and community forums. We have Discord. There's the OpenXR forum at Kronos itself. If you do encounter a bug, bugs happen. We have issue trackers on GitHub for the spec. So if there's a bug with the spec, there's a separate GitHub for the OpenXR documentation where you can go and file those issues. If there's an issue with the SDK itself, you can file a GitHub issue against the OpenXR SDK GitHub project directly. And also, we'd love to know what you're doing with OpenXR. So if you're working on any content that helps people to use OpenXR, tutorial content, example projects, anything like that, please let us know. We're always excited to promote these kinds of things. And might have rushed through the slides a little bit, but we want this to be interactive. This is the last slide here. Please get involved. This is the link to the OpenXR specification and also the OpenXR SDK on GitHub. Thank you very much for attending this presentation. And yeah, love to just open it up for discussion. Full disclosure, I'm filling in for my colleague Jacob, who is really an expert at OpenXR. I will try to answer whatever questions I can, but for a lot of them, I will probably be saying, let me ask Jacob and get back to you. So.
I think you're being too modest. Right, so any questions? Yep. I'm going to bring you the mic, not only so we can hear you, it gets onto the recording too. So.
Thank you, and thanks for a great presentation. So you mentioned that OpenXR is supported by every major player. I think there was a, I see what you did there. But yes, many questions there. There's an obvious elephant in the room, but I have a very specific question. I know that some of the most promising directions in the past have been metal bindings for OpenXR, and I was wondering if there's any update on the recent state of that.
Thank you, because you're right, I kind of misspoke. Let me do the ecosystem part, and then if you can speak about the metal bindings. So Vision Pro from Apple does not support OpenXR, so that, yes, that is the major exception. And it's a question of, obviously, we get all the time. We can't speak for Apple, of course. Of course, they would be welcome to adopt, just like any other company. It is an interesting adjacent observation, though, that the Apple also doesn't support some other Kronos APIs, Vulkan, because they have their Metal API. In that space, there is an open source translation layer, MoltenVK, that takes Vulkan into Metal, and actually works quite well. I'm not personally aware of anyone working on a similar shim layer, but hey, it might be interesting. We'll have to see how that works out. On the metal bindings.
Yeah, I don't really know if I have anything further to share than what you mentioned. There are projects, as you know, open source. There's a strong community. People are building the things that the larger players are not yet.
But we'll see a question about the back-end metal render.
Yeah, there was previous work on Metal XR, but I think it was for other end targets from
anything about that?
I know it's work in progress, but I don't think we're ready to talk about macOS yet.
Right. I haven't heard a timeline, but it is work in progress. So watch this space. But we'll update as soon as that comes, because we've had a lot of people that have been interested in that. Yep.
Are there any initiatives to getting runtime developers to either publish debug symbols or source code to assist with debugging things like crashes that only affect certain vendors? Like, for example, if I have a program that works on the WMR simulator and on Vive headsets, but in SteamVR crashes and I don't get anything more than disassembly, is there any movement there in getting better diagnostics to developers from runtimes?
Not that I'm aware of. OpenXR basically ships the SDK, which is the loader, as well as the documentation specification. Distribution of anything else is really kind of something that we lean on the partner ecosystem for, Monado, for example. But yeah, we don't really have anything to share along those lines. Neil, if you have anything to add, I would be.
No, I don't, but it's an interesting idea. So I wouldn't know, that's like any ideas on how we can improve the developer experience. Go onto the GitHub, start a thread, or onto the forums. Yeah, we'd love your input. Yeah. Now we've got 1.1 out of the door. There is more bandwidth to consider kind of the quality of life things for developers. So yeah, it would be good to get any ideas. Any other? Yep. Brandon.
So you mentioned that there's a work in progress feature to deliver animatable controller models in presumably GLTF format. Do you know if there's a plan to have a publicly accessible repository of those models available, or is it just a binary blob that's going to come out of the driver?
That's a good question. I don't think we've settled on how we're distributing those yet. What would your preference be?
Well, I maintain a publicly accessible repository of GLTF models that are animated for the controllers for use with WebXR. And it would be wonderful if we could combine efforts and make that come up with a repository that is accessible to both uses like WebXR and the OpenXR API.
I'll let Neil take that one.
I actually didn't know that. See, yeah. Okay. All right. I've learned something. No, we should absolutely share resources and co-promote and do whatever we need to do. That sounds awesome.
Neil, we have a question here.
Yeah.
Different. And thank you for running the mic around, by the way.
You said your thing was WebXR input profiles? Yes. Okay, I just want to make sure I had that. Thank you. So I had a question. So I know that currently gauge tracking is an extension in the OpenXR specification, but that was released in 2020, and I think as XR headsets are moving forward, that seems to be becoming a more standardized feature, and some things like Apple Vision Pro, they just went for that as the main interaction method. Is there any, and also one of the things that's preventing me from using OpenXR, if I really want to, but in some, I know you said that all major headsets on all major platforms except for Apple Vision Pro are supported, but some things like the extensions, I believe, aren't supported on all major headsets. So even though like some of Meta's have eye tracking, you support Meta with OpenXR, but the eye tracking extension is not supported. So is there any kind of plan moving forward to maybe have the eye tracking become part of the core specification?
All I can say about eye tracking is it's an easy, hard problem to solve. It's an easy problem in that the data is all there. It's a hard problem in that there are so many privacy concerns around eye tracking data that it is very difficult to get people to sign up to do this in a platform agnostic way. They want to have their own guardrails in place for which applications get that data, how they use that data. So that's, it makes it one of those things that's a little more challenging to work with. But
Yeah, no, I was going to say the same thing. I mean, it's not just a technical functionality. There is security, so that's why it's taking a little bit longer. But I think it goes back to the 1.1 marking, kind of the new phase where, yes, there is, we want, and all of the hardware vendors in the working group share, we need to start using the same. We've done this experimentation. We need to get broader adoption of the functionality that we have, bring these extensions into the core spec. And the gaze tracking will be part of that. But yeah, it's taking a little bit longer because of the security concerns. But yeah. Yep. I think you were first by 20 milliseconds.
Just barely made the cut. I think the answer may be the same as the previous question, but we do a lot of work with Vario headsets for flight training and virtual cockpits, and we were wondering if there was going to be any work for accessing the raw video feed for doing image manipulation, or if we had to do things like night vision effects. I know right now it's only accessible through the Vario native SDK, but I was wondering if it was the same thing with privacy concerns there.
Judging by my work with the hardware manufacturers, yes, it has been very. It's an ongoing conversation. I think everybody wants assurances that that data will remain private and that will only be accessible under certain very constrained circumstances. And we need to figure out how to make sure those assurances are baked into the API itself, so it cannot be misused. And we're working hard to figure that out. We have one more.
So I guess this is a follow-up to both questions. Is there a plan to make, so it seems like the whole privacy concern issue, that seems to be a core issue when it comes to XR. Is that something that will be included in the core API going forward?
It's a good question. I mean, that's what's being discussed. I think it's unlikely that the API would mandate how someone implements their own security protocols, but you need enough hooks and enough structure in the API that people can do what they need to do under the abstracted API. But I haven't been involved in those discussions in detail. But that's the normal way that Kernel's APIs try to work, is to just provide the abstracted interface without mandating particular implementation details, and I suspect for security that will hold true. Yeah.
Sorry. One more very, very small question, and just maybe one thing to bring up in future consideration in respects to eye tracking, and that is kind of just to consider, I don't think, I haven't looked at the specs exactly, but consider having support for individual gaze data. So that could be for certain applications that are more in the medical field, and also with accessibility issues. Some people that might have a lazy eye, for them to be able to say even either choose an eye or be with the application to use both eyes, and yeah. So just maybe something to consider in the future.
Absolutely, yeah. I think multimodal input has always been a core pillar of what OpenXR is all about, and having kind of the ability to gracefully switch between, okay, you have controllers, you have hands, you have eyes, you want to use your head, you want to use only one eye. All of these things should be possible if we're able to build a conformance test such that at the end of the day, we need to know what is the entity you want to interact with and what do you want to do with it. And we will try to build as much of an abstraction around that so that all these different modalities will at least give you the basic functionality of the application, so that it's as accessible to as many people as possible.
But that's good input. We'll make sure the working group gets that. Yeah.
Yeah, I had a follow-on question to Michael's question about metal enablement, specifically regarding the kind of placeholder extensions that currently exist in this spec for metal enablement and swap chain images. I'm kind of wondering if there's a path forward to ratifying those, or if that's going to more come in via the vendor extension path. Because from the out, I'm not being privy to working group conversations, it's not always obvious, sort of what the path forward is on that.
Well, again, I don't think between us we have that knowledge, but come talk to us afterwards. I'll be happy to get you more information. But yeah, we'll take the feedback to the working group that there's been multiple interest in the metal backend. So I know they're working on it.
Yeah,
They-
I can say for sure the work is not abandoned. It's ongoing, but we just don't have a timeline.
Yeah, but no, thank you for interest noted, and we'll give an update now. Before it comes out, there's no reason not to give an update once we have a timeline. So,
Yes.
yep.
I'm not, excuse me. I'm not sure if this question actually even makes sense, but I'm starting to kind of learn more about USD. And I heard some reference to like USD incorporating interaction. Is there, like I said, I don't know if this is nonsense or I don't know if this is something that's already been done, but is there any work towards bridging like OpenXR, things like, hand pose, things like that with like interactions like grab? I know like Unity has their own interaction toolkit, but yeah, is there any kind of open standard being developed?
Oh yeah, I'm not aware of, obviously OpenXR has semantics around grab and all of these other pieces that are at the application layer. But in terms of the data layer, unfortunately, I think everybody is still building what these things are supposed to look like. I know that NVIDIA in Omniverse, for example, we are working on, an interaction paradigm that can be baked into your USD model itself, and you can say, which parts of your USD are interactable and not, and how they're interactable. But as far as I know, we're not really working to put that into the OpenXR spec. However, USD is also an open format. So anything that we end up doing there will make its way, I'm sure, to the open source community.
Yeah, it's an interesting question, and it's a question. It was a good question.
There are no bad questions.
No bad questions, but it was also a good one. Because GLTF is putting interactivity in as well, in parallel with USD, and actually, I suspect GLTF might actually beat USD to the punch because the interactivity spec is already in draft on the GLTF GitHub, and we're planning to get that finalized before the end of the year. And it's quite a sophisticated interactivity framework, based on a node graph. We did actually have at our latest face-to-face, we had a joint session between the GLTF folks and the OpenXR folks saying, hey, we're doing activity, asking your question, we're doing interactivity, is this relevant to OpenXR? The initial response was, it's really interesting, and they're going to review it again once the spec is finalized. But it wasn't clear how you would necessarily directly integrate it, because the way an app normally works is, if GLTF or USD, once those formats define interactivity, it's kind of up to the app how they take the interactivity that's contained in the asset and actually process it in their application. And so it was the beginning of a discussion. Should we or could we take some of those interactivity elements into the OpenXR standard? It wasn't a clear yes or no. But again, we'd love your input. I mean, GLTF deliberately does not define. It gives all the. It's going to do physics as well, but it doesn't say how you implement your physics engine, and so it doesn't necessarily mandate how the interactivity would work. So it's an interesting discussion. Yeah. Any other questions? Oh, yep. Oh, Buchi-san.
So I think a little bit different question regarding the conformance test, and so we might have the several devices, so for example, hand tracking and eye tracking, and so when we pass the conformance test, we need to support the whole functionality, or we can pick up the several function to support, for example, in a middleware or some device conformant.
Yep. I can answer that. So there are many component sensor vendors and camera vendors of the components in an XR system. If you are a component vendor and you can't become conformant yourself, because you don't have the complete system, if your component is used in any XR device that does pass the OpenXR conformance tests, then you can advertise your component that was used in creating that conformant device as OpenXR conformant. And actually the Kronos IP framework applies to that component level usage within the total system. So yes. Yes is the answer. You can become conformant as a component. Okay, any other questions? How are we doing? All right, last call. All right, thank you everyone for coming. It's been great to have you here.
Thank you.